Hi guys, how are you doing? I hope you're all doing well. My name is Brenda and I'm a geospatial engineer. If you're new here, please subscribe, like and comment on my videos. Today I want to introduce you to remote sensing. Just two words, remote and sensing. From hearing those two words, you can be able to tell what remote sensing is. When you talk about remote, when we do things remotely, it means we are doing things without touching things, without having a physical contact. And when you talk about sensing, when you sense things, it means you can be able to acquire some information about something. So remote sensing is acquiring information about things remotely, without touching them. That's what basically remote sensing is. All of us, we experience remote sensing in our daily lives. We all do remote sensing daily, even without realizing it. So think about it, guys. When you're seeing things, how do you think your eyes work? For us to be able to see something, what do you think happens? Do you remember in physics, like how we used to be told that for us to be able to see things, there has to be a source of light. There has to be some reflection from an object. So when you're seeing something, it means there is a reflection from that particular object. And there must be a source of light. And how our TVs work, that's also another example. In the image here, you can see a remote. Have you ever thought about how your remote works when you're controlling your TV? Have you ever thought about what happens? How comes the TV can be controlled by the remote and the remote is far? So that's also remote sensing. The remote itself has sensors that when you press something, assuming you want to change a channel, when you press a button in the remote, it's able to send a signal to the TV, and the sensors in the TV are able to receive those signals, and so they can be able to carry out that command if it's changing the channel, adding volume, whatever it is. So that's just remote sensing, and that's really interesting. This is just the basic definition of what remote sensing is. So I want to give you guys the scientific definition of what remote sensing is. When we define remote sensing scientifically, this image basically shows what happens. The four things around the Earth are the satellites, and they're able to acquire information about the Earth. They can be able to detect objects in the Earth and come up with these satellite images which display information about the Earth. So that's what happens when we say we are doing remote sensing, basically satellite remote sensing. This here explains the process in details. So we have the sun. The sun emits electromagnetic radiation. And down here, these are the objects in the Earth. We have forest, there's water, vegetation, land, roads, houses. These objects, they receive the electromagnetic radiation from the sun and they reflect it. And when it's reflected, it goes back to the sensors. That is the satellite. And when the sensors receive this information from the Earth, it records this information, and from that information it can be able to tell what this object is. And different objects emit, they reflect different types of radiation. What roads reflect is different from what water is going to reflect, and it's different from what trees are going to reflect. So the sensors can be able to tell that this is something else from this. It can be able to tell this is water, this is forest. And so after receiving that information, it sends that information to the ground stations. These stations will be able to analyze this data, and the output is going to be a satellite image. That satellite image is a spatial data, which can be used in very many different ways. So basically, the output of remote sensing are satellite images. There is active and passive remote sensing. When we say passive, it means we require a source of light, the sunlight. The active, on the other hand, doesn't require the sunlight. It's just whereby the objects in the earth emit radiation. But for passive, there needs to be that source of light so that there's going to be a reflection. When we talk of active, it's like microwave stuff, microwave remote sensing. There's just emission of radiation, and this I'll talk in details about it like in the next videos. Remote sensing, like any other thing, has advantages and disadvantages. So among the advantages, we have the fact that with a satellite you can be able to cover the earth as many times. Some satellites can cover the earth more than once in a day. So you can get so many images. You can be able to do analysis, like weather analysis. You can be able to tell what weather was there in the morning and how it changed to in the afternoon, and that's very impressive. This can help us in monitoring our climate and things like crime. The fact that you can be able to monitor what's going on in a short period of time, many times in a day, that information is very important. When we talk of accessibility, places like a mountain, if we do a ground survey, it can be hard to access such points because you can find that it's very bushy, or even dangerous wild animals could be there. So it's really hard to map such places when you're doing ground survey. But if you're using a satellite image, you can easily map such places. And with satellite images, you can map very large areas in a short period of time. If you compare doing a ground survey of maybe a county, it will take you months compared to just obtaining a single satellite image of the area, and that's very easy. When you talk of disadvantages, some satellite images are very expensive. Not so many are free, and the ones that are sold are expensive. So it's not something that you can just decide that you're buying anytime. Also, some satellite images can be affected by weather. Like you can, when the weather is cloudy, rainy, you can have so many clouds and it will interfere with the visibility of the earth. So you will find that yes, you can get a satellite image, but you won't be able to see what's on the ground because of the clouds. So now you have to find ways of removing those clouds. That's challenging. Though nowadays there are many algorithms of removing these clouds, but I'm just saying it's a challenge also. Remote sensing has many applications, as you can see. And in Kenya, the agriculture part is the one that's very important, because agriculture is one of the major economic activities in Kenya. We can use remote sensing to do to monitor our farming systems. We can be able to map our produce. We can be able to estimate the yield of our crops, or we can even be able to predict. So this is very important for farmers. If they can be able to predict how the yield is going to be, that will help us in deciding if they're going to do the planting or not. If of course the yield is going to be low, they'll decide not to. Also, we have the climate change. You can be able to monitor climate change, especially because now that's the problem that we are majorly facing, not just in Kenya but the whole world. We also have the flood analysis. In Kenya we have the problem of flooding, especially in the Budalangi area. So we can be able to analyze the impacts of these floods. These applications, they are very important, and these are just the very few of them. There are many others. So you can see clearly remote sensing, it's something very vital. We all need it. We are probably already all using it. So this video is just a basic introduction to what remote sensing is, and in the future videos we'll get into details of the various types of applications and even various types of sensors and satellites, because there are so many. So guys, this is the end of my video. I hope today you've learned about what remote sensing is. So guys, thank you so much for watching this video. Please like, comment and subscribe to my channel. Thank you so much.